Hey guys, it's Turpy here. I thought I'd go ahead and remake a video that I did, just kind of memeing because I wrote this thing, but it's fairly cool. And it goes over some basic concepts in encryption, not high-level encryption. This is going to be plain text, so be encrypting like Word files and stuff. Nothing of other like data types other than strings, but it carries a lot of the same concepts, and it's a fairly cool exercise. So here's the main script that I have. You can ignore this. I was trying to figure out how to GUI, and it didn't go well. So here I have arguments for what is the main script. This is the file encryption script right here. This is what runs the encrypt text module that I've written here. And it is command line because I can't GUI. So here we have our full if else block. I'm not sure if there's a better way to do it because I'm still not great for checking for arguments and coming up with pop-ups that are still from the UI that I didn't pull out of here, specifically these pop-ups for the command line arguments. And the arguments that it takes are the file name, of course, what file you want the encrypted file to be named, and here you provide an initial key value, and as far as I'm aware, it can be any integer value, but the higher the integer value, the longer it will take to calculate a valid key, and we can go over why that is. We will go over why that is, because this is a fairly interesting twist on a few classic ciphers that used to be used for, just encrypting messages in letters between people, military ciphers. The Enigma machine was a cipher, essentially, a very complex one. So we get down here, and we get down to our file handling stuff. So right here, we read in the message from, not here. Here, sorry. We do. We read the content of the file, and then we print the whether or not you were encrypting or decrypting, and we collect the start time to see how long it took to encrypt and decrypt, and mainly this was debugging to see how long my correction for wraparound on the plausible keys, as you'll see, it's an interesting thing, works. So here, we check to see if we're encrypting or decrypting, and we call the encrypted or decrypted text I've decided to call translated, because it's either translated into ciphertext or it's translated into plain text. So translated becomes scrambled by the first cipher in the encrypt text module, and it's encrypt message. Now, encrypt message, if we come over here, excuse me, let me bring this down. Encrypt message is here in transposition encrypt. It is a transposition cipher, so each string in the ciphertext represents a column, so it's a column row type thing, right? So we convert the ciphertext into the ciphertext into a list and then we add the blocks, right, that are the rows and the columns, which are determined by the key that you pass it, and this is the key that you input with your argument. Unless I'm wrong. So yeah, it does take the key and the message, and the key determines the amount of different columns that you have to, or essentially blocks that you have to scramble the text into. So it is variable. This is one of the parts of it that is variable, where the user inputs a key, and that helps determine, I guess, a block size that it uses to encrypt the message with. And it goes for the length of the message and puts the pointer, which is where it is in the message, to where it is in the column in the ciphertext, and then it joins the list into a string and returns it. And then we go into the Caesar cipher. Caesar cipher I have made super complicated to the point where it's not really a Caesar cipher anymore. So what I've done is, this is the cipher alphabet. So these are all the possible characters that we can encrypt, right? And what I've decided to do is that if the key is greater than the length of your cipher alphabet, right, then you take the square root of that key and as an integer, and use it for this method, which is keystring shuffle. Now, keystring shuffle, we initialize a variable that will be the first half of our new cipher alphabet. So what we're doing is we're scrambling the cipher alphabet based off of the key and the length of the message. Well, no, based off the key and the length of the cipher alphabet. Sorry. And what that does is we get the length of the input string, and we loop over the input string in reverse, because we take the ordinal index and subtract it by 1 to make it take the cardinal index, subtract it by 1 to make it an ordinal index. So technically it's going in reverse, because index down here is being decremented by 1 for every iteration of the loop. It de-increments the index while adding that index to the first half of the new cipher alphabet we will return, while the index is greater than the given key. Take the index of the first half of the cipher alphabet's stop point, so it's stopping de-increment, and use it as the stop point exclusive, right? So it will not include where the first half stopped for the lice list. So you're just going to take, because we now know the end point, we can just slice the rest of the list and add the two together and return a new cipher alphabet that is scrambled and not in the same state as it is here. So then we can take our translated variable, right, what we're going to return, which is the scrambled message, or descrambled message, and for the symbol and the message, if the symbol is in the cipher alphabet, right, we're going to get the decrypted or encrypted symbol from the cipher alphabet by getting it from find, and then if the mode is encrypt, we take that number and add it to the key value to get its proper value to encrypt or decrypt with. For the decrypt, you subtract it. So yeah. So to handle if the number is still greater than the length of letters, which means that it is not in the range of the cipher alphabet, then you keep subtracting it. And if it reaches 0 and goes past 0, then you add the length of letters to it to handle for wraparound. And else you just use the same symbol if the decrypted symbol happens to be, if the decrypted or encrypted symbol happens to be the same, given the key and the initial state of the cipher alphabet. So that's probably pretty confusing. I guess the best thing to do, this is Lovecraft's books. This is a bunch of Lovecraft's books. And it's all in all of these different format and everything. And this is it encrypted. Right? And this was me trying to get a hash fail to see if I could decrypt it with a integer that could have given us the same square root. So if we want to run this, we just and for brevity, I'm just gonna in file is yarn and will be 1000 just to prove that, and so mode is so here it is with that key, and if we want to decrypt it, we just here it is, decrypted from the test. So, boom, it works.